Hey, welcome back, students. Here in this video lesson, we're going to focus on how to find the heat of a reaction. In a previous video, we learned about what the heat of a reaction was. And again, just to recap, the heat of a reaction is going to be the heat that is either lost or gained during a chemical reaction. Okay? And so what we've got here is we've got a sample problem. And I just want to go through here and help you solve what the heat of this reaction is going to be. Just a little bit of a recap, however, remember that the heat of the reaction is identified as Q, and that's going to be lowercase q. And Q tends to follow the general format equation of, the way I refer to it is as MCAT. And so M is for the mass times the specific heat, and specific heat can be represented with a capital C with a little subscript P. It can also be represented with S. So it depends on which site you're looking at. And then you're going to multiply this times the change in temperature, which is going to be represented by delta T. You could also see it represented with a parentheses around delta T. And so what you want to do is kind of go through in the sample problem here and identify all of the pieces that pertain to this. So if we look at the problem reads, a sample of water with a mass of 958. So this part right here is going to be your mass. And so we can go ahead and label that right off the bat. And so we can say here, this amount here is your M. And it undergoes a temperature change. And so here's your temperature. Remember that the temperature change here is going to be the difference between the final and the initial. And so notice the key word here, it goes from, which means that this part right here is your T initial. Degrees Celsius, and it goes to, so this is the next section here, this value is your T final. I'll just represent that as TF, also in degrees Celsius, and they want to know what is the heat change of this sample of water, and they want the answer in joules. And so what we're looking for here is they want us to identify what Q is. And so using the equation that we have from above, we'll bring that down. We'll say Q is equal to the mass times the specific heat times the delta T. And delta T, if we take this part here, that delta T is nothing more than here the temperature final minus the temperature initial times the specific heat times the mass, and this is going to be equal to Q. Okay, and so all we need to do at this point is go ahead and plug everything in. So let's go ahead and do that, and we'll do it quickly here. And so Q is equal to the mass. Here is 955.8, and this is going to be in grams. And then the specific heat here is going to be a value. Previous video should have identified it, but if we didn't get it at that point, let's just give you what the specific heat. The specific heat of water is very specific, and essentially it is the amount of energy that is needed to raise the temperature by 1 degree Celsius for a particular mass, and that mass is 1 gram. And so for water, that value is 4.184 joules of energy are required for every gram, and this is going to be degrees Celsius. And then we're going to multiply this times the change in temperature. So the final temperature here was 88.96 degrees Celsius minus the 15.24 degrees Celsius. And so if we go ahead and go through and identify these here, we should be able to, again, get the final answer. And so what we're going to do overall here is we're going to go ahead and change the color of my pen here. Let's go and change this to yellow. Notice what's going to happen is that when we look at this stuff here, the degree Celsius here is going to cancel with the degree Celsius here. And so that'll be a very easy one for us to go ahead and cancel. And we can do that first by resolving the value here of the degree Celsius. And when we take these values here, notice the temperature here is in Celsius. So you could just leave it in Celsius and do the difference. And so we'll take 88.96 and we're going to subtract from that 15.24, and that'll give you a difference here of 73.72 degrees Celsius. This Celsius here will cancel with these degrees Celsius there. remember that this particular section here is not divided by, this is just me simplifying the numbers in green. And so this number here is overall in the numerator. And so it should be represented like this over 1. Okay. Now, on the other side of things, though, we'll notice here that the grams here are going to cancel with the unit of grams here, so we can go ahead and cancel that out right now. So that'll cancel here and here. And notice if we have all of this left over, the unit that we have here at the end is going to be joules. So our final answer should be in joules. And so let's go ahead and multiply all of these out. 955 times 4.184 times 73.72, and that should give us the final answer. So the answer here is Q is equal to 294811.233. Now, just a quick review, make sure that you pay attention to the sig figs. Overall, the sig figs here should be 4. So when we look at this, our final answer should be reported to the 1, 2, 3, 4. Should be right here. Here's the line. And so overall, though, Q for us is going to be 294800. Remember, this unit here is in joules, and so here this is your final answer for this particular problem. You could also convert this into kilojoules, in which case all you have to do is divide it by 1000, and then you'll have the answer there. But because this problem asked us for the answer in joules, then we don't need to convert anything, we just leave it like this. So that's this problem. So if you have any other questions, go ahead and reach out to me. Otherwise, if you haven't already done so, subscribe, keep watching, keep learning, and we'll see you in the next video.